Okay, so we have all our triangle similarity theorems. We know that if we have two congruent angles, then we have a similar triangle. If we have three proportional sides, then we have a similar triangle. If we have a proportional side and congruent angle and another proportional side on the other side of that congruent angle, then we have similar triangles. But why do those work? So we're going to talk about that real quick. You'll see side angle side is away from these two because these two can actually be explained together. So we're going to look at this picture right here that I made. I made this picture, and you're probably familiar with how these things work. I can drag this up or down and keep the sides the same, or I can drag this left and right and keep the up and down the same. Or I can grab a corner and keep everything proportional. So as you see, if I grab this and I lengthen one side, I'm not keeping these sides proportional, then I'm definitely changing this top angle. That top angle is changing, and since that top angle is changing, the sides are changing as well. If I can do that the other way as well. See, I'm definitely changing that left angle right there as I do this. That's because I'm not keeping, as I'm stretching it left and right, it's still staying the same up and down. But if I grab this here, it's going to keep all the sides proportional. So let's see what happens there. Are any of the angles changing? They're definitely not as I'm doing that. So as I'm stretching the same amount up and down as I am left and right, that keeps the sides proportional and that keeps the angles the same. So you can see, since I'm keeping all the sides proportional, all the angles are going to stay the same. And that's the definition of a similar triangle. Proportional sides, congruent angles. So I can say that the exact same way the other direction. Since I'm keeping all the angles the same, all of the sides are going to be proportional. I can change this left angle here if I want, but you can see that that's not going to keep the sides proportional. Just the same way I can change the other angles. It'll definitely change your proportional sides. But if you keep all the angles the same, your sides remain proportional. So to look at side angle side, we're actually going to use an online program called GeoGebra where you can play with geometric figures. It's actually free if you want to check it out. I made this right triangle here. 3, 4, 5, you might recognize that as a right triangle. It's a pretty popular one. So what we're going to do is keep this angle B, and we're going to use side A, which is 5, as we can see, side 3, which is 3, as we can see here. So we're going to take that and we're going to give it a scale factor. We're going to dilate it. And that is what a scale factor is, right? A similar triangle has a scale factor to the next one. So we're going to go here, dilate from a point. We're going to dilate this figure from this point. Scale factor of 2, and we'll see what happens. Hopefully they remain proportional. So with our new guys, we now see that our new sides, our new A is 10, our new B is 8, and our new C is 6. So we now have proportional sides. The scale factor was 2, so everything doubled. 5 to 10, 4 to 8, 3 to 6. These are now all proportional sides, and we know that this angle stayed the exact same, right? Because it is the same angle. So no matter what I do to these proportional sides, these triangles are always going to be the same. So we know that this is still a right angle, and we know that this angle is congruent to this angle because these are similar triangles. Okay, I hope that proved it to you a little bit, and now you believe me more than just telling you that those theorems are true.